So I've started recording. We can just cut this bit off and edit or whatever. But okay. Hello, everybody. I'm Aaron. I've got Mark here with me. Say hi, Mark.
Hey everyone.
And Mark is going to help me build my first Gall app. Hopefully, get some ship to ship talking and maybe some browser to ship talking, and we'll see how that all goes. So, a little bit about the ship setup we have here. We have a fake Zod and a fake Marzod. Um, we've set those up so they can talk to each other. Um, and I did that with Urbit dash L, which turns on networking, and dash F, which makes it a fake ship, and then Zod. And I did the same for Marzod. Um, so those are both running. We've synced base to my local um, Unix, so that should share files between Zod and Marzod automatically as I update them. So yeah, let's get started. Mark, so what is a Gall app? What are the things it can do, and what parts of that are we going to use today?
A Gall app is essentially a, I would say, piece of Hoon code. More accurate would be to say a core that is managed by Gall, which is Urbit's application sandbox system, sandbox/management system. And it facilitates like whenever an application wants to use some system functionality, so anything from writing to the file system to sending out a message to a foreign ship, Gall facilitates the the events coming out of that app and being routed to the appropriate vein, the appropriate kernel module, and then routing the response to that eventually back into the application again.
Okay, cool. And so what's the main mechanism for that? You have arms of your core with magic names, and they resolve to certain values, and somehow that does all the functionality.
Yes, we do in fact have magic names in Gall apps. This is not entirely uncontroversial, and we do definitely want to heavily improve the Gall developer experience. But right now, yes, we do have arms with special names where you can, by implementing a function under those arms, you can define the behavior of your application that it performs when, for example, it gets sent a command.
Yeah, I mean, a lot of frameworks work by specifically named hooks, so that does make sense to me. But early days, all subject to change, but this is...
Yeah, the problem here is that the special names aren't especially well documented. So it takes some figuring out sometimes to try and see what specific name you need for the thing you're trying to do.
Okay, cool. So where should we start? If we want to build the simplest possible Gall app, what do we do?
The simplest possible Gall app. Well, we start by creating a file in the app directory of our mounted base disk.
Ooh. Okay, yeah, so what's in there? So these are sort of all the built-in apps here, what are already in there? Cool, and so we'll make a new one there. Let's do it. What should we call our app?
Example.hoon?
Fine with me.
It's generic, it's safe.
All right. What do we put? Does it just a core rune at the very top level?
So we need a special kind of core here called a door.
Okay.
So that is bar cab.
Great.
Which takes two arguments. It takes a bool from the Gall namespace and the type for your app state.
Bool and the type for your app state. So this is we put some face on type bool, and then some custom app state also. Is that right?
Yes, and because we currently don't have any state, you can just make that the null type.
The null type, like this?
Yeah.
Cool.
And then bool would come from the Gall namespace, so that would be bool call Gall.
Like that? Cool.
Yes. And then in the core, the simplest thing we can get for interactive functionality is a poke-noun arm.
Yeah, you'll see some, because of the recording and the call, it's a little slow. So sometimes you'll see ridiculous things happen. But
yeah, I was going to say, you're typing really, really fast there. But...
So that will just happen and I'll fix it. So we made a poke noun arm.
Yeah. And what you want that to produce is a gate. So a Hoon function which takes a noun as its input.
Cool.
And then if we put a face on that, we can then within the function refer to it by doing sig pam arg, so it gets printf'd when this code runs.
Mm-hmm.
And then here you'll see the first slightly suboptimal part of interfacing with Gall is that all of the Gall specific arms in your application need to produce a list of moves paired with updated application state.
Okay.
So because we have no side effects here, our list of moves is empty, so just sig. And then our updated application state, by the way, I'm phrasing that you would think that is just sig, but really what you want to produce is your updated application core instead of just the state within that core. So what you'll commonly see is this pattern.
Yeah, I have seen this a few times. So this lets us, oh, well, in this case, we don't need to make any changes, but if we were actually changing, we could do this to replace our state. Does that look right?
Yeah. Yeah, that looks right.
Might as well leave it for now since we'll come back to it. Yeah, and that's because dot, like a core is called with itself as the subject, so this dot resolves to the subject, which is the core itself. And then if we want to change S, we can do that. So yeah, it took a little bit to wrap my head around, but we'll probably be assuming some basic Hoon familiarity here, and this is more about the less documented Golly bits. So all right, so this should work, and we should now be able to do whatever a poke is to this app if I save it.
Yes, I do have already a little style nitpick about the code.
Sure.
Is that when you make a core with arms, you don't actually indent the arm names. You only indent whatever is under those arms.
Okay. There we go.
Yeah, that's it.
All right, so we check in on our Zod ship and see if this synced in properly. Yeah, we do see example.hoon, but then I fixed the style and saved again, so we'll wait a second for that to sync properly. So now I think we have to start this app or something, right? Just because it's an app doesn't mean it's like loaded or running or whatever.
Yeah, apps aren't running by default. You need to explicitly start them.
And
worth noting is that once you've started them, there is no way to stop them.
Okay, great.
So you better make sure you're not starting Skynet here.
Uh-huh. For now, I assume there will be a way to stop them in the future, right? Or is that a okay? Just checking it wasn't some wild design decision. Now, as we make updates to it, it's already running. It will be sort of swapped in for the new one. Is that right?
Yes, that's right.
So just because we can't stop it doesn't mean we can't upgrade it.
Mm-hmm.
Cool.
That's actually a good arm to look at next after we've seen the poke arm in action.
Mm-hmm.
There it is. Oh, still syncing. Okay, we should be able to run bar start example now.
I think that the sync with Marzod is slowing it down a little bit more.
Seems to be, yeah. So like the reason we're developing on base here, and you can see it from the printfs here, where it says sync succeeded, is that both your local home desk, where you run your code from, and your kids desk, where your sponsee ships get their updates from, get their updates from base in turn. So changing base causes the changes to like flow down through those dependencies.
So that's sort of the over-the-air updates that the docs talk about a few times. Is that right?
Yes, that's the subscription of Marzod to your kids desk.
Cool. All right, so now we start example.
You should start it with example as a constant, so sen example.
Right.
Otherwise, it's trying to resolve that as a variable into a constant.
Yeah.
And not finding anything.
That makes sense. Okay. Should we see any particular output, or it just does it?
It just does it.
So great. How do we poke this thing?
So we poke this thing by doing call example and then passing in any noun.
Call example?
So call as in colon. Cool. Yes. And then pass in a number, for example.
And so this is the way that we poke the app from Dojo, but there are other things that might poke it. Is that right?
Yes, that's right. So if you, for example, type in a string here instead of a number, you will see it prints that out as a typeless noun, so no pretty printing or nothing. This is, of course, because we take the poke noun takes the input as just a plain noun. The reason poke noun is the very first example we start out with and try to use from Dojo is that in Dojo, if you pass data into an application or anything, then the noun mark, so the like meta type information of the data is defaults to a noun, which in the poke arm, if we had say JSON we were sending, it would we would do a slightly different Dojo incantation, which mentioned the JSON mark explicitly, and then in the application, we would have a poke-JSON arm, which would then take JSON as input.
Okay, so Now, marks are sort of, um, they're like bigger types, right? So I don't think there's a number mark and a string mark so much as there's a noun mark versus JSON mark, right?
There is actually a mark for atoms also.
Okay.
So something we could do is implement a poke atom mark and try using that.
Okay, but there's not poke tape or poke chord?
No, marks for those are not implemented, but if you would write a mark for chords specifically, then you could use poke chord, yes.
Okay. And if we wanted to send a poke with a given mark from Dojo, is that possible?
Yes. So you would still start out with example, and then you would prefix the data with PAM noun, which is the default, or PAM JSON in that specific case, and then your data again.
Oh yeah, cool. All right. Cool.
So if you have a bunch of different marks that you would want to do conversion between, so for example, you have a noun that you know can turn into JSON, you would write example PAM JSON, PAM noun, and your data, and it would run it through that conversion pipeline.
So this is basically a Dojo feature, right? So we do JSON PAM noun, and then is there a way to type a JSON thing? Is it
null would just be a valid JSON value.
Just nil?
Yeah.
Cool. Okay, so this, does that turn a noun into JSON or turn a JSON into noun?
It turns your sig into a noun, and then turns that noun into JSON.
Okay, but we don't have a poke JSON arm, so then this might not work currently?
Yes, so if you try running this.
Cool. All right, yeah, I think that's good enough for now. I don't know that much about marks, but now I kind of know where to go and play with them sometimes. So let's see, we could add some state to our app, or you were, yeah, we could add some state, or are there other things besides poking that we can do? What should we do next?
So next we it might be interesting to look at what happens when we update the code for our application. So if we add a new arm called slus prep.
Slus. I don't know what that is.
Yeah, that's the pronounceable for double lus.
Oh, okay.
I'm not sure if we're phasing those out or not. Lus prep works too. And so this gets called whenever your application gets updated.
Okay.
And it is a gate that takes an argument in the form of a unit state type. So in our case, that would just be unit sig. And that's then.
Is this the state from the previous version of the app?
Yes.
Cool. So like old is a good name for it.
Yes.
Cool.
And it's a unit because if you start your application for the first time, you do not have state yet, obviously.
Okay. So we could do something like, what do we resolve? The same thing as here? Is this the standard return is list of moves and new application core?
Yes.
Okay. So let's just do something like, in both cases, do the same thing, but we want to say whether we had old state or not. So we'll use a sig pam to do that. Saying no old state. Oops. Jeez. Or sig HoldState. So this looks right. We check whether the unit is nil or not. I think this is right, so let's try it.
Yeah, I think so.
So we should see one of those two now without doing anything, right? Because it notices the file update, and so it updates? Or do we have to manually...
Yes. No, as soon as the source code changes, it attempts to call the prep and update your application in that way. If anything about the prep fails, so for example, it would not be compatible with the old state type, or there's a, or like your application fails to compile in the first place, then it will not update your application.
So the old one will continue running?
Yes.
Okay. What happens if, like, a poke fails, crashes?
If a poke crashes, the sender of that poke will get sent the stack trace.
Okay.
So there's like more specially named arms that deal specifically with like taking responses for specific actions. So obviously for subscription, you would want to deal with a response, but for things like pokes, also you may want to do different things depending on whether it succeeded or failed.
Is there a list of all the ARM names anywhere, or is it sort of scattered across the implementation of Gall or something?
That's a good question. I remember someone working on that kind of documentation recently, but I'm not sure if that's live yet. You would probably find that under Urbit docs.
Okay. Would there maybe be a pull request open for it, you think?
Not that I'm aware of.
Okay. Well, maybe I'll search for that later. Maybe put it in the links to the video if it does exist. Cool. So all right, nice. So we got initialization of our app. We got poking our app. What's up next?
Did we see the outputs for this?
Oh, good question. Gall example. Sync succeeded.
Syntax error.
Line 11. Huh.
Let's see. What did we mess up about this?
I don't know. That seems right to me.
It does. Interesting. Maybe it wants a new line at the end of the file, but like it should have yelled at us earlier in that case.
Yeah, I mean, it did say the syntax error was at character 3, which doesn't even exist, so...
Yeah, there is a weird issue with that where, like, it supposedly expects trailing new lines, but then sometimes it works just fine without them. So it's kind of confusing, kind of misleading sometimes.
Yeah. I noticed at some point, I think there was a style guide and it said no empty lines ever.
Yes.
Is that still a strong recommendation? That like doesn't really appeal to me. I like using blank lines. Is there a strong reason for that, or it's just convention?
There is a strong reason. If you use blank lines, the Hoon police will come to your house.
Okay, got it.
Yes. No, there is like it's basically just a stylistic rule.
Yeah.
It won't cause the compiler to yell at you yet. I'm not sure if we'll ever enforce it for the compiler.
Yeah.
But like we'll definitely will definitely strictly disallow new blank lines in code that wants the space-rated Hoon stamp.
That wants space what?
So we have different names for like levels of code style that we try to work around internally. So like the first is land rated, which is just ugly and terrible code. You have air rated or sky rated Hoon code, which is good but could be made better, more readable, etc. And then space rated Hoon conforms to all of the style recommendations and is very good, high quality readable code.
So you might have that, high, like you might require space rated code for like Arvo core code, and then like maybe official libraries could maybe be in the middle, and then land is just kind of the standard for whatever.
Anything that is land rated should just be updated and cleaned up. To be honest, like ugly Hoon code or like poorly written Hoon code is generally very hard to read.
Right.
So it just shouldn't exist in the first place.
All right. So I'm seeing this sync succeeded here, but I don't see anything about HoldState unless I'm looking straight over it.
No, it's not there, no.
You would have expected it to be there, though, right?
I would have expected it to be there, but there is also an issue where if the syntax error or like compile error, whatever, is the exact same as it was the previous time it tried to compile, it just doesn't print it sometimes. What you can do is update, say, the poke noun arm to prepend some value to whatever it's currently already printfing, so that like you can see if the change actually went through.
Cool. Let's do that in a second. I just shut down the Marzod. I figure once we get into intership communication, we can bring it back up, but to skip the syncing every single time. Cool.
I mean, it would still go through all the individual syncs.
Yeah, but it was slowing down our feedback cycle.
Yeah. We can just boot up like a fake binzod or something.
Yeah, okay, maybe. What were you saying about adding a value to the poke? So let's see, how do I... Well, I guess I can just change it, right? Or we can output a cell with, something like this. So that should be a significant change that we can notice by poking. And we can know whether it was updated or not, and whether it just didn't print the thing for some reason or failed to update.
Yeah, like the so this too is part of the Gall developer experience. Right, like sometimes it like just behaves a little bit weird, and you just throw some printfs at it and try to see if it actually does anything at all.
Yeah, well, early days, that's what you get on the frontier.
Yeah, you get used to it soon enough, which is maybe not good. But like most of these things are known issues. And, like Gall development is definitely, I wouldn't call it a pain point. Like you can certainly like do things with it. It's functional, but it's very, very rough still. And like there are, it's also like structured kind of, I wouldn't say simply, but like there are many more things it could be doing to like take work out of the developer's hands, basically. And lots of thought is happening internally on what it can and what it should be doing, and how that should tie into the rest of the system.
Right. And maybe putting some of this kind of stuff out there, we'll get a few more hands on the problems and maybe raise our standards if a bunch of people are unhappy about it too. Cool. So example 4.
Yeah, so it's still complaining about the same thing in that case.
Okay, so maybe it was not the new line. There's some other problem that we can't see. Okay, so slus prep gate hold the unit, which is should be.
Oh, I see what we're doing wrong.
What's that?
On line 9,
yeah,
we're doing a what sig check, but what are we actually checking?
Oh, we're only giving it 2, right? So this should be old.
Yes.
Great. Nice catch. Thank you.
People have been yelling at their screen for 5 minutes now.
Yeah. We could put usually YouTube comment will be they figured it out, just have to wait till we could put a little skip annotation or something. Put some good stuff in the meantime, so. Cool.
Yeah, that's always fun. Like, there's so much to talk about with Urbit. Like, any idle time you can basically fill with either like theorizing or like discussing technical details or what have you. So.
Yeah, there's a lot here. What? Okay, let's assume this works. What are we doing next?
What are we doing next? Let's see. We'll probably want to add some state to the application and try updating it.
Cool. How do you deal with what if there were a few different old versions of your app that it might be upgrading from? So then this type, do you have to sort of do the union of all the old state types here?
So generally what you can assume is that if someone is way behind on the application version, but you did push out newer versions sequentially, then they will get those updates sequentially also.
Okay, because of the sort of full processing of events, it will go through the whole upgrade chain.
Yes.
So they would have to sort of not be syncing with your desk or whatever, have the old version running, and then like somehow manually copy in the new version, and then that can crash, and that sort of makes sense.
Yes. So if you only support upgrading from the previous version's state, then yes, that can give them trouble if they like walk off the paved path in that sense. But you could, and this is done in some veins and some applications. I'm not actually sure, but where you like take the state and you tag it with a version number,
right?
And then you can be like, oh, if it's on version 1, then we upgrade it to version 2 and then version 3 instead of going straight to version 3.
Cool. Yeah, that makes sense. All right, yeah, and we got our old state message here. So awesome.
Cool. So something we wanna do before we continue is something we should have done from the get-go is cast the output of our arms here.
Sure. So the output of the gate, right?
Yes.
Cool. So let's see. So what exactly is the purpose? Is there more than one purpose, or is it sort of explicitly for human readers, or is it making sure to sort of discard information if there's a too much information problem, or
so primarily it's for you, the developer, that you don't unknowingly mess this up, and for the reader that they know what's being produced. Of course, since all the Gall arms produce the exact same thing, there's some less value there. But if you if you messed up those sig this as sig lines, and instead of producing this, you would produce the number 5.
Uh-huh.
Then I don't think Gall would actually pick up on that, the fact that you returned a quote-unquote broken core,
Right.
since it's not even a core, until the next time it would try to call your application.
Uh-huh. Okay, cool.
Which can give you really strange errors, like, oh, there's no poke harm, but I've certainly implemented it.
Yeah, I could see that being quite a trip. Okay, what's the best way to specify this type?
What you will often see done is people using the...
Gonna be some crazy, like...
That's
That's right, right?
That's close to what you'll see in older code, yes. What you'll see most of the time in modern applications is that they use the quip function to generate the type for this.
Okay.
Where quip AB is a shorthand for a list of A and then B.
Okay. So quip move this, something like that? Or just that?
Yeah, that's it. I think it's with the underscore, yes, for the type of this.
And move is a type.
Yes.
That'll come from like Arbo somewhere.
It does, but generally what you want to do is define it in your application code itself. First, primarily because I don't think Arvo's move type covers everything you can do. And secondly, because it's good practice to have your application explicitly specify the kind of effects it can produce.
Okay, so right now, so you would often have an arm to do this that would then resolve to a type somehow?
Yes. What you'll see in most applications is that they have a separate core for their internal types. So at the head of the file, you can go and write a regular core, so bar_sen, and then close that also. And then here you can put your types.
Okay.
So type arms, this is a sort of recent change. Instead of lus, they use lus buck, indeed.
And you don't necessarily need to do that, but the advantage is it sort of moves you into the type space. So you don't have to do things like prefix with underscore to get the type, because it's as if you're typing here in a gate. It's meant to be a type. So is that right?
Yes, it like tells the compiler that, hey, the context that follows is a place where we specify a type, not a value.
Cool. Is there a name for those sort of two parser modes, value versus type?
I think just value versus type. Yeah.
Okay. Cool.
And you would like if you need to switch between those explicitly. So like if the default isn't what you want, then you can prefix with a comma.
To get into type space?
Yes.
Cool. Okay. So what is our move type here? Right now it can just be like nothing or something.
A move type is made up of two things. It is made up of a bone and a card, where a bone is a number which is a reference to the communication channel that the move is going over. So kind of like a Unix socket reference. And then the card is the actual description of the effect that's going out.
Okay. Yeah. So we could definitely dive pretty deep into this. I think I don't want to right now. So a bone, let's see, that's like a socket, and there are things called ducts also, and is a bone sort of like a reference to a duct without having the whole duct?
Yes, so ducts are on the kernel level.
Okay.
What Gall does is, at least if I'm not mistaken, what Gall does is it maps bones to ducts to make sure, like, oh, if you're sending an update to this bone, then we'll make sure the update ends up with the subscriber that opened this this duct.
Mm-hmm. Okay, cool. So when we do a move, it's a card describing the change and where it should go.
Yeah, so it's a cell of bone and card, and you can type that as you say it.
Cool.
And then card, you still have to define locally.
And for now, we don't have any cards. Is there like a never type where if we use it before sort of adding something to the type, it would explode or something? Sort of like a union of nothing. I don't know.
I'm like, since we're never producing any moves,
yeah,
I don't think like doing an arbitrary type here will give you trouble.
Okay. I'll just do something
like it can just be sig or noun, sure.
Cool.
But like if you were to actually produce this, then Gall would yell at you and be like, "Hey, this isn't a valid effect."
Right. Okay, that makes sense. Cool. Quip is shorthand for a list of things and then one of this thing. Cool.
Yeah.
All right, so now we have done that. We've defined all necessary types, and so we'll just put that cat. And then, let's see. It appeals to me to do something like return quip. Oh, except then we don't have the core type up here, so we can't quite do that.
Mm-hmm.
But we could do it. Oh, Jesus. We could do it in our main core if we feel like being a little spicy.
Sure. I don't think I've seen that done in other places, but I suppose it's valid.
We'll see. Cool. So we added some casts, and then we were going to add some basic state. I do have to get going by 2. So let's add some really basic state, and then we can pick up with episode 2 some other time.
Sure, that sounds good. We can certainly jam in some state real quick.
Yeah.
So, under the assumption that this sync succeeds, we will want to, or at least it's very common to define a type for your state.
Let's just sort of do a number. Should we do a counter that we can increment or lower?
Yeah, we can do a number, sure. What you'll probably want to do to like make this more ready for expansion is make it a type that is currently like it's a cell of an atom basically, which is just like, I think it's purely okay, not exactly purely writing style, because then you can be like, oh, counter tis atom.
Yeah.
But at this point, it's like mostly a stylistic stylistic change.
What else? What's the second half of the cell?
You can just close the cell right now.
Oh, what's that do?
It just makes. I think it just resolves to counter tis pat without like it being a cell.
Okay.
But you would still be able to access it under counter.s instead of s directly.
Mm-hmm. Okay. And so wrapping it in a cell is just kind of convention that makes the diff nicer later and implies that it might grow?
Yeah, like generally you would write this like multi-line style, where you use the buck call rune specifically.
Why is this not lined up?
So you would,
like this?
Again, if I may hate on your style, you would put the buck call underneath the line with Lost Buck State, and then you do because it's not a core, but rather a regular quote unquote list of whos. You close it with tis tis. Yes.
Cool. How's this? A little goofy still?
A little goofy. Most of the time, you'll see the the list start on the same line as the opening run. So counter directly after the.
Okay.
Yeah, like so.
Cool.
But that's what official style says.
Yeah.
I bet plenty of people would agree that you can go either way.
Yeah. All right. So how do we have to update all our other arms and stuff to?
So because all your other arms live inside the door, and the door is what specifies the state type, you would. Okay, I was gonna say you would only need to update the door like this, but then the prep, of course. While currently the unit sig is still correct because the previous state was just a sig, going forward, you'll want to change that into unit state. But if you do that right now without saving first, then it'll yell at you like, oh, there's a mismatch when calling the prep arm because we're passing in state of the type sig, and we really expect the state of the type atom.
Yeah, so your prep will sort of always lag behind one, I guess, right?
The argument to it will, yeah.
Yeah. So...
But sig is also just an atom, so practically this would this would work, I think. That's what I meant to say.
Okay.
But yes, that's something to be mindful of when changing your state. There is also the option, of course, to say, oh, prep takes a noun, any old noun, and we just produce our application with its
right
empty state.
Which basically we're doing at the moment. We're ignoring it. So.
Yeah.
Okay, so actually something we can do is basically make the state something, and then in our poke we can print the state instead of boom. So value should not be a state. I changed this. That's wrong. But if we basically print the state within our poke, then every time we poke it, we should see this current state.
Yes. So, it might be interesting to, for the poke, take a value that is an atom and then update the state with it after printing.
What happens if we send because we could poke it with a cell, right? And would that show up here?
No, there is no cell mark. But if you would, the way it's defined now, if you would call it with a noun that is not an atom, it would, I want to say nest fail.
But didn't we do that? We poked it with a string, a double quote string earlier.
Sure, but then we're still taking a noun as the argument, instead of strictly an atom.
Okay.
The name of the arm is only informed by the mark, not the contents of its data.
Okay.
So if we want to only accept a subset of that, which would be confusing, of course, to anyone reading the interface of our application as just poke noun. But if you want to accept a subset of that, that is something we can do.
Okay. so now when we poke it, we should print the old state and then update it to whatever we poked it with.
Yes, I think this might work, but you might also need to do counter.s instead in all the places where you currently have s.
Right.
Or at least in the change this cases.
Yeah. I think it is really. I have a wireless keyboard. It's related to that, but.
Oh yeah, that. I was gonna say, are your keys like physically hanging or something?
Yeah. Next time I'll find a good wired one to plug in. Okay, so that probably works now. Let's quick run over it. State return. Okay, that seems good to me. So let's save it, see if it works.
Well, it already yelled at us about a syntax error previously, but it looks like we have that resolved.
Right. Well, yeah, and then normally you can't just put cores right after each other like this, like logically in Hoon, but it just this core is made with whatever subject the whole thing is called with, and so then it has that subject in it, and then this one is called with this core that we just made as its subject, right?
Mm-hmm.
Okay, cool.
Yeah, like the like putting two cores directly after each other like this is a bit of a special case. I saw your issue about this on GitHub. I don't know if anyone has answered yet, but like there is something that like turns that into basically evaluate the door against the first core.
Someone mentioned it might be a Ford feature, but come on.
Like basically, it's just saving you 4 spaces of indentation.
4
or like
spaces.
2 spaces, depending on how you write it.
I mean, and another rune, right? You would need to do the.
Yeah, you would put the tis gar at the beginning.
Like that, yeah. Okay, come on. I want this to finish so we can see our success.
Yeah, this is a long drum roll.
Yeah, maybe I'll find a more powerful computer to go from next time.
You can probably run like a 32 core AWS instance or something.
Yeah, that'd be nice. Okay, we got old state. Sweet. Now we can poke it. And we should see 8. And then, yep, we see counter equals 8. And now we do 7. And we see counter equals 4. And now there's a 7 in there. All right, we made an app that we can poke with state. And we know how it's initialized and stuff. So that is awesome. Let's wrap that up as the very beginner episode, and next time we can do some more advanced stuff.
Looking forward to it.
Yeah, thanks so much, Mark. It was great chatting.
Anytime, Aaron.
All right, see you guys next time. Bye.
Bye.